Hello, everyone, and thank you for joining us today for our HashiCorp Solutions Engineering Hangout hosted by Russ Poslow. I'm going to go ahead and record it so that you can all get the recording afterwards. So today we're going to talk about HashiCorp Nomad. HashiCorp Nomad is an easy to use and flexible cluster schedule that enables that organization to automate the deployment of any application on any infrastructure, any scale, handling anything from containers to VMs. Russ will show you how to get started with Nomad right from the very beginning of what it is and how it works through downloading it and getting it running on your computer within minutes. I also want to note that the Hangout is recorded and the recording will be made available after post-processing, usually within a day or two. I'll email it out to all of you. So the demo will be about 20 minutes and then we'll allow up to 30 minutes afterward for questions. So please go ahead and submit your questions through the portal and then we'll get to them at the end. So with that, let's go ahead and get started. Take it away, Russ.
Awesome. Thank you very much, Amanda. So hi, everybody. Greetings from a dark and gloomy London, unfortunately, today. It's been raining quite bad, but that's just the UK weather. So yeah, today I'm going to go from 0 to wow with Nomad. One thing I will guarantee is we're going to start at 0. Hopefully we'll get you close to wow, or at least to, that's interesting. We've got a lot to get through, so let's get started. So the agenda today, I'll do a brief introduction, but then I'm going to sort of talk about what is Nomad. Now, hopefully, we've got lots of people on the call who have at least heard of Nomad or maybe know a little bit about Nomad. Perhaps you're using some of the other HashiCorp tools and you want to know what is Nomad, what can it bring me in addition to Terraform and Vault and Consul. I'm going to go through some important nomenclature. So there are some terms I'm going to be sort of using throughout this presentation. I thought I'd kind of spell those out kind of early so we all know what we're talking about. I'm going to do a very, very simple architecture overview. I'm not going to spend a huge amount of time talking about kind of the full architecture and all the various different ports and things that you would need, because I really want to get to step 5 as soon as possible, which is starting simple. Okay, so if you've never used Nomad before, you want to understand how to literally get started from nothing, this hopefully is the talk for you. Then we're going to sort of show how you can run your very first job. Then I'll show how to scale things up. And then we'll talk a little bit about some of the things you can try next after this. And then we'll have time at the end for Q&A, as Amanda said. So very quickly, who am I? I'm Russ Poslow. I'm one of the solutions engineers for HashiCorp. I've actually been at HashiCorp for just coming up to 2 years. The start of next year will mark my 2-year anniversary. Even though I've been here for 2 years, I still feel sort of fairly new with Nomad. We've got some people in my team that I work with here in London who really are kind of the experts and my kind of go-to people. So I figured it's about time that I learned a little bit about Nomad as well. I thought, what better way of doing that than to do it all together with everybody on a webinar. So we're going to go through some of the basics together. I'll go through the kind of the steps that I kind of first went through recently to kind of get you started on the Nomad journey. So the first question is, what is Nomad? So Nomad is a modern lightweight workload scheduler. The question then is, what is a workload scheduler? So back when I was a server administrator, I was the workload scheduler. So application teams would raise a ticket. They would throw their code over the fence to my team, and then we would arrange compute, storage, and networking. The obvious problem being it wasn't a particularly fast or scalable solution. Also as well, we weren't fortunate enough that every time we had a new application to run, we could buy additional equipment to run it on. So this usually meant we needed to find a suitable home for the application on the existing infrastructure. Now, thankfully, skipping forward to today, we have Nomad that will do all of that hard work for us. So essentially, we'll create a giant pool of compute, network, and storage, and we'll let Nomad place workloads where it's most efficient. Now, Nomad supports containers, traditional VMs, and static binaries, amongst other things, because in practice, it's fairly rare to find an organization that's moved all of their workloads to containers. So we still live in a world where we've got different types of technology that we're using that we need to manage. So Nomad supports, obviously things like Docker, but also things like Java and binaries running natively on the host operating system as well. It uses simple job config files. We'll see some examples of this in the demonstration in a little while that allows people to understand and deploy workloads onto Nomad. I've kind of already talked about this, so that kind of idea of automatic and efficient workload placement. So instead of me having to find a server that had capacity to run this particular application, which used to be quite difficult, Nomad will actually perform an evaluation, a calculation, and it will work out where that workload actually needs to run. It also supports a number of update strategies as well. So when we've deployed our workload, at some point we're going to have to perform an upgrade. And there are different types of upgrade strategies that are supported inside of Nomad. So there are things like a rolling upgrade, where we upgrade a set number of machines. So maybe we update 2 instances of an application, wait for them to become healthy, then we do 2 more, and then they become healthy, and then 2 more and 2 more, and so on until the entire application is rolled out. It supports Canary deployments, whereby we leave the existing application alone. Maybe we bring up 1 or 2 instances of the new version of the application. We do some testing, all looks good, and then we perform a promotion, and then it updates the rest of our application. And then some people are using Nomad to do kind of blue-green deployments, whereby you leave your existing application where it is, you bring up an entire fresh set of the application, all the various different components, a full deployment of it. If everything is okay, you flip over to use the new one, and then you take the old one down. Fully automated failure recovery as well. So if our workloads are running perfectly, that's good news. But if there's any kind of issues with them, they stop, they crash for whatever reason, then Nomad will actually restart those for you. So why Nomad, I guess, is the question. So we know what Nomad is, but why would you use it? So if you've got a mixed environment, which pretty much everybody has a mixed environment that you need to support, Nomad's a good fit there. If you need to move your legacy applications to the cloud, maybe you're not quite ready to put everything into containers right now, but you like the flexibility and the elasticity that perhaps the cloud provides. Nomad really kind of is that bridge between those legacy applications and modern ways of working. Get maximum efficiency from hardware. So typically servers probably operate around about 2% utilization. Obviously this can vary, I appreciate that. But maybe with Nomad, we can get to 20% utilization of our servers, which probably doesn't sound like a massive jump. But if you end up doing the maths, it means that if we previously needed 100 servers to run your workloads, with Nomad, we'd only need 10. So Nomad automatically works out where to best place your workload. You can define additional parameters or constraints. So maybe it needs some particular hardware. It needs certain amounts of CPU and memory. Maybe it needs a certain operating system for it to run on. Maybe you've got a Windows application that doesn't run on Linux. So you need to put a constraint in to say, hey, when you schedule this workload, make sure you put it onto one of our Windows machines, because that's where it needs to run. Self-service provisioning is kind of really important as well. So none of us want to be in a world where we raise a ticket and then we have to wait, and then we get to the front of the queue, and then there was some kind of issue, and then it gets thrown back to us, and then we have to go through the whole process again. So the idea is, if we can enable self-service provisioning with Nomad, we can put the control back into the hands of people consuming the resources, and then we can abstract away all the complexities of operating the underlying systems. But seriously, why Nomad? Okay, so I've talked a lot about scheduling. Maybe you're convinced that schedulers are the way forwards, but why would Nomad be your scheduler of choice? So for me, one of the massive benefits of using Nomad is its simplicity. It really is easy to use. Hopefully we're going to get to that wow stage later on, and you'll see how kind of easy it is to get started. It's a single binary. The mental model for Nomad is very simple. It doesn't have half a dozen, 8 different components that you have to manage and update and maintain. It's literally just a single binary. So upgrading, operating it is very simple. The flexibility, we've kind of already talked about this. If you've got that kind of mixed environment, containers and VMs, if you're running service jobs, which are the kind of the long-lived jobs, or batch jobs, maybe you need to do some kind of short burst of processing, maybe you need to do some payroll processing or some number crunching. Nomad's really good for those things. And it also runs across Linux and Windows, where most people are doing it. It does actually work on macOS as well, which is good for me today, because I'm going to be running it on my MacBook, although I don't have too many people who are running macOS in their server environment. Scalability and performance is a real kind of key differentiator of Nomad as well. You might not need the very, very highest levels of performance, but we wanted to push Nomad to see what it could do. So a couple of years ago, we did the 1,000,000 container challenge, where we spun up 1 million containers in less than 5 minutes. Here's a graph of the containers being scheduled. It's 267 seconds it took to schedule 1 million containers. There is a link so you can actually find out more about the challenge. I did hear one really cool story about this. So we've got one customer that uses high performance computing, and they saw this and they looked at it and went, "Wow, you could spin up 1 million containers in 5 minutes. That's really cute. But we want to use Nomad to do 40 million containers. Can we do that?" Thankfully, we can. Nomad is exceptionally performance. It scales very well. And we operate on the principle that if we can scale up that high, then we can scale down too. So wherever you are in that sliding scale, Nomad's got you covered. Cool. Starting to get a little bit more into things now. So I wanted to talk about some of the key terms that we use inside of Nomad. So the first is a job. So a job is a specification. So it's a file that you provide that declares the workload that you want to run on Nomad. So all of the job files that I will show you as part of the demonstration, you'll see right at the top it says job. That's kind of like our highest level of configuration. And within that, there are various different components that we'll actually specify. So inside a job file, there will only be one job. Inside of that job description, there will be a number of task groups. So a task group will contain one or more tasks that all need to be run together on the same client node. So they actually need to be co-located. They need to be running next to each other. So perhaps you're running some web application, and there is some logging component as well that also needs to run alongside that web application. We want to put it on the same system. We would put those things inside of a group. Now we can have multiple groups. Everything inside of a group will run on the same node. Different groups potentially could run on different nodes. Anything inside of it will run on the same, unless in my case I'm going to run everything on my MacBook, so everything will just be on a single node. So inside of the task group, we would have one or more tasks. So they're the smallest unit of work in Nomad. Probably makes more sense when I flip to this screen. So inside of a task, we would specify the driver that we want to use. So this is where we say we want to use Docker because we want to run some containers. Or we would say I have a Java application that I want to run, so I'd use the Java driver. Or I've got a virtual machine that I want to run, so I'd run QEMU or QEMU, however you want to say that. So that's where we would actually specify this within here. And there are certain parameters that we would provide inside of that to say we know which container we want to run or what virtual machine image that we actually want to run as well. Allocations. So an allocation is the mapping between the task group. So inside of our job, we have a task group, which has a number of tasks that are running in it, and a client node. So if I've got a task group that contains 10 different tasks, for example, they need to run somewhere. So Nomad works out where it's going to put those 10 tasks, and it goes, that machine over there is a perfect fit for this. I've done the calculations, and it goes and drops that allocation onto that machine. It does that by performing an evaluation. So don't need to worry too much about the evaluation side of things unless you really wanted to kind of be digging deep into Nomad. But the evaluation basically is Nomad deciding where it's actually going to place that allocation based on a number of different conditions. Bin packing. So Nomad works on the principle that it wants to be as efficient as possible with your resources. So look at this. I love this Tetris. Oh, it's going to go. And no, terrible. Really hate that. But the idea is Nomad will try and use your resources the most efficiently. You've got all kind of different tasks that need different CPU and memory and different kind of hardware drivers and all these different types of things. It will try and use those, it'll try and pack as many of those tasks into a worker as possible. Cool. So let's dive into the architecture just a little bit. So there are basically two main types of agent that run inside of Nomad. Even though it's actually the same agent, the same binary that runs, it runs in one of two different modes. So the easiest one is the client. So that's basically somewhere you need to run your Docker containers or your virtual machines. So it runs tasks. they are the clients are managed by the servers. So there's kind of a number of servers that kind of form a cluster together. So it's highly available. One of those will operate as the leader, and it will basically replicate certain information to its followers. Now, inside of a cluster, so a cluster being a number of servers and a number of clients, the servers is always going to be an odd number. It uses the raft protocol, so it's a consensus protocol. So you always need an odd number. Typically, this is 3 or 5. It doesn't make sense to go to 7 or higher because it actually reduces performance. Obviously, it doesn't make sense to have just one. So what you see me do here in the demo today is not a highly available solution. So don't recommend that. But it's either 3 or 5 servers. And then in terms of the number of clients, anywhere between 1 and 10,000. Okay, so we actually need to run our workloads. It will scale into the thousands. Awesome. So now this is the fun bit. So we need to start, but we're going to start simple. Really going to start from the very beginning, from 0. So it's unlikely that we need to schedule 1 million containers today. Certainly my MacBook will struggle to schedule 1 million containers. I couldn't do that. We are going to start simply. So we're going to run Nomad locally. So I don't want to have to find machines to kind of try this on and set up networking and all that kind of stuff. If I just want to try this right now today as quickly as possible, I'll run it locally on my machine and schedule some work on my machine. Caveat obviously being, you may be running a different operating system from me. Even you might be running the latest version of macOS. It might actually operate slightly different from the way that my machine works. So by all means, check the documentation that have the latest information if there are any particular differences between your operating system and kind of how that works. I have cheated ever so slightly in that I already have Docker installed on my MacBook. Simply, we don't have time to download. I think it's a several gigabyte installation size these days. So Docker's already running on my Mac, but that's the only thing that I've already got pre-installed. So the download and installation process is really kind of simple, pretty straightforward. You visit nomadproject.io and there's a download button and you download it for Windows, Mac, or Linux. Then you unzip it and then you are done. So basically, it's a single file. It's a single binary. I recommend putting it somewhere on your system that you can find if it's part of your path. So instead of having to type the full path to Nomad to get it started, if it's inside of your path, you can just type Nomad and then some commands. So with that being said, let me show you how easy it is to download and install. So if I jump over to this screen over here, if I go to nomadproject.io, I'll just bump the size of this up ever so slightly. So this is the Nomad website. Obviously, there's lots of information on here. There's kind of an intro getting started. There is a guide section as well. So once you start to become more familiar with Nomad and you want to try some of the various different deployment strategies and those different types of things, the guide section is great for that. The documentation, obviously, all the documents about how things work is all there, including the API reference as well. Everything that you do inside of Nomad, you can also drive through the API if you wish to. But the one that we're really most interested in here is the download. So you hit download, you find your operating system, you find your particular architecture. So Windows 3264, Linux 3264, Mac OS, everything is 64-bit these days. You click it and it downloads a zip. I'm not going to do that because I've already kind of, I did cheat a little bit and I kind of did that. But literally, you download the zip and unzip it and it'll have one file inside of it. So let's take a look at that. So basically, I've got Nomad and I've still installed it onto the path on my system. So literally, this is it. It's one file. It's 93 megabytes for this particular version of Nomad that I have. But that's it. There are no other components to install. Literally download the binary, put it in your path. And then that's it. So if I did like just a nomad -- help, for example, it provides all of the commands that are available. If I wanted to get more information about one of them, so maybe I wanted to do nomad agent -- help, it'll give me loads more information on that particular command. As you can see, there are loads of different parameters that you can pass inside of here as well. So that's Nomad. That's how you download and install it. Download the zip, unzip it. So the next thing you do is you want to actually run Nomad. Okay. Now we've made this simple as well. There is something called dev mode. So we're going to start Nomad in developer mode, in dev mode. Really good for doing testing on. Basically, it runs as both a server and a client. So the thing that is managing the workloads is also the thing that's going to run the workloads. Not something that I recommend that you do in production. You should have the separation of those things. Also, ideally we'd want a highly available cluster when we do this in production. And the real key thing is data is not persisted. So everything is in memory when I'm using dev mode. So as soon as I stop the process, I lose all of my data. So don't try and do this, stop the process, restart it and go, oh, where's all my data? It will be gone. Really easy to start it. You just do nomad agent -dev. So if I go back to my command line, clear that. I say nomad agent -dev, run this. So it's going to start the nomad agent, give it a second for it to get going. Basically what it'll do is it'll fingerprint your system. It'll find out all the capabilities of your system, how much memory, CPU, those things you have. It also tries to work out what drivers that you have available. We've got a little bit of an annoyance here on Mac OS. Basically, when Nomad tries to do a detection for Java, macOS helpfully pops up this dialog box, which you click OK on and it goes away. But obviously Nomad is constantly trying to fingerprint the system. So this dialog box keeps coming back, which is really annoying. So let me show you how to fix that. Go back to here. Oops. Also what it does is it takes control of my, takes the window focus as well, which is really annoying. So if you're getting something like this, you're running it on a system, you can actually disable certain drivers. So I'm going to disable the Java driver. There is a config that is within here. So if I pop this into a new tab. So this piece of config here, I'm going to add this into my Nomad installation that I'm running, just so that basically, yep, you see that message keeps going up all the time. It gets really annoying. Oh, look, this is the webinar. It should be on now. So I'm going to do this now. And the way that you do this, I'm going to stop this. Nomad agent -dev. And you see I've actually passed it within here. So normally what you would do is you take that config that I just showed you in the documentation, so this bit here, and you put it into a file on disk, and then you would just say -config equals, and then the path to that file on disk. Now I'm being super lazy. I'm using a bit of bash magic, which basically is going to put it into a temporary file and then pass it through to Nomad. So it's pretty similar to how I did it before. You may not actually have to do this. I do it just because I find the macOS prompt really annoying. And that means it won't pop up now. So that's gone. Let's go back. Slides. Cool. So you saw that Nomad take 2. Nomad has a user interface. It's available on port 4646. You can view all of the different clients and servers that we have, and we can run and view jobs. So I'm going to show you the interface real quick. So I'm running this on my local machine, so I can go to this port. So local machine port 4646, and this is the UI, and I'll just bump this up just a little touch. So at the minute, obviously I'm not running any jobs, pretty obvious because I've literally just started this. I can see all of the different clients I have. I'm only going to have one because this is my Mac. I can see the capabilities, so I can use the Docker driver. I can use the raw exec driver, and we'll talk more about that a little bit later. The other things I'm not using, I don't have QEMU installed. I don't have Java installed, obviously, as we kind of saw. There's lots of information about my machine, the version of Mac that I'm running, and the kind of capabilities that it has. Similar with the servers. So again, I'm running a server. I'm running Nomad 0.10.2, and all that kind of information is within there. So that's the UI. We're going to come back to the UI quite a bit during the demo, so we'll come back to that in a bit. Running our first job. So we define our job in a job file. In this case, I'm going to run a Docker container. It contains an application called HTTP Echo. All that does is it renders a HTML page. You provide an argument to that Docker container, such as hello world or something similar, and then it renders that page for us. It also listens on a particular port, so we provide it with a port number, so it actually listens on that particular port. So let's run that. Let's see what that looks like. Now, this is the code that I've prepared earlier. Really kind of simple. So this is the job file that we talked about. So it starts with job, and then it has the name of the job. Certain things it has, such as a task group. So I've got a task group. There's one of them running, and basically I'm running the Docker driver. I provide some configuration to it. So, this is the image I'm going to pull from the Docker hub to actually run. I've also need some resources. So I need some network connectivity to this box so we can actually see something that'll be a bit boring. In this case, I've got just saying that I need a 10 megabit network. It's not particularly high performance website. I've opened up this port called HTTP to port 8080. Now this port could be called anything. I just called it HTTP. It makes sense, but I could have called this thing, this label here, anything, echo port, or I don't know, something of this nature. So if I copy this and go back to the UI, if I go to run job here, all I got to do is paste this in, hit plan. This is the other kind of cool thing about Nomad as well. Before I actually deploy this, I can do a plan and it's going to say, yep, that's going to succeed, or it's going to say, no, there's going to be an issue, there's going to be some kind of failure. In my case, there's nothing there, so it's going to create this job. So I can hit run on this. And then it goes away and performs an evaluation and says, right, where can I run this workload? It's a pretty easy calculation for it to make today because there's only one place it can actually run this. So there's information about, okay, we've got one running. We've got information about the allocation down the bottom. So the allocation, remember, is I need to run this task somewhere. Where can I run it? I'm going to run it on this particular client. If I go into the allocation, I can see I've got this address here that I can go to. If I go to this now, okay, this is my application that's actually running. So that we just saw from the job file. Really, really, really simple. This is a Docker container that's running on my machine. In fact, I can prove this. If I go to here, and I do a Docker container ls, I can see that Docker image or that Docker container actually running on my machine. Real simple, right? So already you're running your first job within the first 20 minutes or so. The next thing we want to do is scale up our applications. So if we want more than one instance of the application running, which almost certainly we do for high availability, we can increase the count. So in this case, we change the count from 1 to 5 and we resubmit the job. So let's scale up the application. So if I go back to here, go back to jobs again, I'm going to run the job, paste this into here. So it's the same code as before, but I'm going to change the 1 to a 5. I'm going to plan this and you get some kind of error. So the error that I'm basically saying is Nomad is saying, I can't deploy this. You've asked me to deploy 5 and I can't. And the reason is because there aren't enough port 8080s available across your entire estate. My MacBook has only got one port 8080. So there are 5 things that all want to use the same port. Obviously, I can't do that because it can't be shared. So basically it's saying, sorry, I can't do this. There is a port collision because they're all trying to use port 8080. So we need another way to deal with this. So I'm actually going to stop this job because I'm not going to run it anymore. It's not particularly useful to me. So I'm going to hit stop on this. Yeah, I want that to stop. And then it kills it off and stops this. So now we need a way to scale up our application where we're not going to get port collisions. So the way we do that is by making our job dynamic. So as we've seen, multiple tasks can't all share the same port. So because we're using a static port, it's causing a collision. But what we can do is we can use a dynamic port assignment. So I can run many instances on my MacBook that all use a random free port such that they don't step on each other's toes and there are no collisions. Now, there's a number of runtime environment variables that can be used inside of your job files that will basically make your job file dynamic as well. So instead of having to hard code a port in there, I can change my job file to be dynamic and use these variables where I actually need to specify what the port is running. So let's take a look at that real quick. So again, if I go to this job file, I've bumped the count up to 5, but I've started using these. These are my environment variables that I'm actually using. So this will replace Nomad port with the HTTP port, which is what I've called down here. And also notice now that these braces are empty. Before it said static equals 8080. I'm not using a static port anymore. This is going to dynamically assign a port to all of our different things. So I'm going to copy this, go back to our user interface, and submit the new job. Plan that within there. This looks better. That looks good. Run this. Okay, give us a few seconds. So it's just trying to start all of these various different jobs. So in a moment, I should start to see some of these running, which I can. So if I go into one of these again, oops, go into one of these. So I can go into this and I can see my job. So it's running on 127001 on port 312220. Okay, that's good. It's dynamic. Let me pick another one. Try and pick a different one. Okay, this is running on port 21066. Open this one up. Okay, so this is running on a different port to this one. I think we can probably already kind of see the problem. I can go into this and I can keep clicking through this and find out what the port is, but it's kind of annoying having to find out what the ports are. They're dynamic. I don't know what they are. It was different from when I practiced this. Obviously, these are all different every single time it does this deployment, which is kind of annoying. So we need a way to fix that. Let's figure out how we do that. We do it by using something like service discovery. So when we schedule our workloads, as you saw, the ports change, the host could change as well. Okay, it's all running on my MacBook, but when I start having tens of thousands of workers, it could be anywhere inside of my environment. My applications still need to be able to talk to other resources and components. So they need to know where they are, what is their IP address, what host are they running on, what port are they running on. And a service catalog is that thing that provides that way to find other services. So when you start something up, it registers itself inside of a catalog, and then everything can query that catalog and go, that's where the web server is, or that's where the instances of the web server are. There is a famous service discovery product. It's called Consul, which is another HashiCorp product. Maybe you're using it. So with service discovery, we need to solve two challenges, first of all. So one is we need to run Consul somewhere, and we also need to register our application inside of the registry. The good news is we can solve both of those really easily with Nomad. So running Consul on Nomad. There are different ways that you could do this, but the way that I'm going to demonstrate today is using the raw exec task driver. What that basically means is instead of it running inside of a Docker container, it will run it in macOS. It will run it natively on my machine. Nomad, the job specification, has this thing called an artifact stanza. So basically within there, I can specify where I want to download Consul from, and it will unzip it, and then it will run it for me as well. So I don't even need to install Consul on my machine. I can actually put that description inside of the job file, and it will do it all for me. Nomad also supports Consul natively, so with the service stanza. So let's see that. So we need to run Consul and register our application. So if I go back to here, here is the job file that I'm running for Consul. It's very similar to what we saw before, but now I'm using this driver raw exec. So it's going to run it natively on my Mac. It's going to run the binary called Consul, and it also provides a couple of parameters to it, which is agent dev. So like all of our products, we have a dev mode, so we can actually run Consul in dev mode, which is great for our purposes. This artifact stanza here basically says where I actually want to download this from. So this is actually a link to our website, so it's going to download it. Fingers crossed my bandwidth is doing okay. It's going to pull this down and actually run it inside of my cluster, natively on my Mac. So let's go and look at what that looks like. This job actually, I'm going to kill this one off. I don't need these containers anymore. So if I was to run a job now, and I'm going to paste this definition to here, hit plan, all looks good, run this. So again, it's going to download Consul to my machine. It's going to unzip it. The artifact stanza in there also does the unzipping of it for you as well. And then it starts it running, and already it's running. Now let's take a look at what Consul looks like. And this is not a Consul workshop, unfortunately, but kind of a little brief look into Consul as well. So this is Consul, the UI, and it's running. Nomad itself has some health checks and things that it will put into the Consul catalog. Difficult to say. So that's what I can actually see being registered here. So I can check the health of Nomad. Now I need to register my application within here as well. So again, very similar to what we saw before. If I had to flip between these two, you'll notice the only difference is this service stanza down here. So this basically says, hey, when this service starts up, go and register it in Consul. Go and tell Consul that this thing exists, tell it what port it's running on and all those different types of things, such that I will have that inside of the catalog. So if I was to run this code, I go back to my jobs, run this job, paste this within here. So everything that we've seen before is exactly the same. It's going to run 5 containers inside of Docker, dynamic port assignment, but it's going to register the services. So I'm going to plan this, looks good, run this, and away it goes. And again, it's going to go through the same process where it starts up all of these containers. You know, I can still go into each one of these if I want to, and I can see the port. But if we start looking inside of Consul, we can start to see that they're actually registering inside of here. So now I can kind of query this catalog and see all of the different services that are running and all the different ports that they're actually running on within here as well. So that's how simple it is to register a service inside of Consul. So dynamic ports can be queried from the Consul catalog. They're all available inside of there. That's really useful for machine-to-machine communication. Okay, so if I was a machine and I wanted to talk and find out where the HTTP echo application was, I could use DNS or the API interfaces of Consul to do a query and say, hey, where is that machine and what port is it running on? Sadly, I'm running a browser. browsers aren't particularly good at using service discovery. DNS is fine, but browsers won't actually find out the port that they're actually running on. So we need to introduce some kind of load balancing strategy. So I'm going to introduce you to Fabio. No, not that Fabio, a different Fabio. Fabio, the HTTP and TCP reverse proxy. So it's going to operate pretty much as a load balancer for us. Really, really great product. This was originally developed by eBay. It's now maintained by the community. So this isn't a HashiCorp tool, but it is kind of a popular tool. It is not by any means the only load balancing strategy that exists, but this is just one that I like using because it auto configures itself using information from Consul. So I don't have to configure it. I just start it up. It's a single binary again. I love things that are single binaries. Big fan of that. It's really easy. You download a binary and you run it, and away you go. Take a look at the Fabio website if you're interested in more information about that. So running Fabio. Hopefully by now you're starting to get the feeling of how we're running things. So in this case, this is the Fabio job specification, very similar to what we saw before. I'm going to use the raw exec again. So this is going to run on my MacBook natively. I'm going to pass the command Fabio. So that's how we start Fabio. We download the binary called Fabio and we run it. We also pass a parameter to it. So by default, Fabio basically picks a random host. I don't want to do that. I want to do it like a true round robin. I want it to go in order 1, 2, 3, 4, 5, 1, 2, 3, 4, 5 as I kind of rotate between them. The artifact stands are very similar to before, but in this case, because the file name, if I was to download it, it would be called fabio-1.5.13.go blah, blah, blah. That's kind of a mouthful to type in. So I basically said, download this file, but just call it Fabio. Put it in this local directory. So that's what that part does. So let's schedule this and see what happens. Back to this. Run this job. Place this within here. Plan this. Run this. Give it a few seconds for Fabio to actually start up. And that's it. So basically, Fabio is going to detect that Consul is running on my system. Yes, I do want Fabio to talk. It's going to detect that Consul is running on my system. In fact, if I was to go back to Consul, I'd probably see Fabio pop up. Fabio also has its own health checks within here. So Fabio knows that Consul exists, and automatically, it's actually using these tags. It's a topic for another day, but basically it's using these tags to auto-configure all of the HTTP echo instances that are running and put them inside of Fabio. Now, one of the cool things that we can actually do is we can take a look inside of the allocation. So in this case, I can see this particular task. So remember, an allocation is one or more tasks that are running on a particular node. In this particular task, I can take a look at the logs as well. So this Fabio process is, it's downloaded it and it started it. Let's take a look at the logs. So all the information that I need about the Fabio logs is in here, and I can kind of see things. So automatically connected to Consul, which is running inside of my local data center. And there is an admin interface available on port 9998. So this is running on my machine. So if I go to 998. So basically this is saying it's detected. I literally just started this. I didn't do any configuration of this. So if I go to Fabio, hit the port 9999, which is the non-admin interface, the actual load balancing interface. The particular route to my application is HTTP-echo. So let's see what that looks like. 127.0.0.1 on port 9999/HTTP echo. So there we go. So from a browser point of view, if I could just hit refresh. So this is port 29163. This is instance 2, instance 3, instance 4, instance 5, and then back to the first instance, 29163, instance 2, instance 3, instance 4, instance 5, back to instance 1. So now I've got load balancing for all of my different instances of my application that I can view from the browser, and it will automatically round robin me to each one of those different instances. So that was Fabio working with Consul, which is being used with Nomad, which is putting the service discovery information into Consul, and it all just works. It's magic. So the last thing we're going to do is update our application. There are different update strategies that are available inside of Nomad. The one I'm going to cover today is a Canary update. Basically, leave those 5 containers as they are, bring up a new container with a new version of my application. I can do some testing against that. That'll actually be in the load balancer, so we'll see it. If that looks good, I'll do a promotion, and then it'll update all the other 5 of our systems. So let's take a look at the updating our application. So if I compare this to the previous one, you'll see that there's this additional stanza within here. So this update strategy, basically I'm saying when I perform an update, what are you going to do? Now in my case, I've set Canary to 1, so it's going to bring up one instance of the application. Okay, I could set that to 2. That's fine. I could have a couple of them that I could test. If I set this to 5, it would essentially be a blue-green deployment. Okay, so in the real world, I've got 5. I bring up 5 of my new version, and then if that's good and I do a promotion, the new one stays where it is and the old one goes away. So that'd be like a blue-green deployment. This max parallel basically says when I hit promote, how is it going to upgrade all the other ones? Now I've just gone for it. I've just set 5. So basically, if I promote this, it's going to update all the other ones at the same time. And also the thing that I've changed is my application is now, has this piece of text in it, which it didn't have before, which says update successful, but everything else is the same. Let's go back to Nomad and schedule this job. Go back to jobs, go back to run job, and go down to here and hit plan. Now this is an update of my existing job, okay? Hence why this isn't like a brand new create. It's going to ignore 5 of them because I'm leaving my existing application where it is, but I'm going to bring up one Canary to actually do some testing, and it's going to update my, my application code as well. So I'm going to run this. And then eventually what I will see is I've got this new version of this application. So this is version 1 of my application, which is now running. So I could do some testing against this system to make sure it looks okay. So let's go back to our Fabio load balancer and just hit refresh a couple of times till it takes me to, I should see, there we go. So the existing 5, haven't touched them. They're still working. Is this good? Yeah, it looks good. If it's not, I could kill the Canary off and say, that didn't work. Let me try again. But this looks good. I'm happy with this. The new version of my application looks really, really good. So if I go back to Nomad and then I say promote Canary, basically what that's saying is update the rest of my application with the new version of the code. Now, because I've set this to 5, basically it's going to kill off all 5 of those jobs. So if I was to go to the load balancer and hit refresh, yeah, it's kind of stuck at the minute because there's only one that's running. That's the Canary. Because I decided to trash all the rest of my my 5 nodes. My 5 instances. But eventually what we'll see is we go back to here, is eventually you'll have all new versions of the application running. So there's me 1 healthy at the moment. It's still kind of deploying them. My MacBook's starting to croak a little bit. But eventually what we'll see when my MacBook catches up is we'll see this application and it'll be running 5 different instances. We'll come back to this in a second. I think my MacBook's just on the go slow. Okay, cool. We'll come back to that in a second, see how it's going. Awesome. So what did we cover in the last 44 minutes? So I showed you how to download, install, and run Nomad. Again, really simple. You go to the website, you click download, you download the zip, and you unzip it. Easy. Run multiple instances of a web application. So we started off with one real simple web application, and then we scaled it up. So we had multiple instances of that web application running. I showed you how to do service discovery and health checking. So we used Consul. As I said, there's loads of information about Consul out there, so you can find out more about service discovery and health checking. But you saw from a Nomad point of view how easy it was. We just put that additional service stanza inside of our job code, and basically it registered that service with Consul automatically. I showed you one of the load balancing strategies that you could use. Fabio, as I mentioned, is one of them. It's not necessarily the only one. You might be using Nginx or F5 or some other kind of system that you want to use. And then I showed you updating our application, and I will check in a moment to make sure that has finished updating. So hopefully we're kind of in this position now. We've kind of gone from 0 to kind of wow to the land of make-believe. I'm not quite sure if we're in the land of make-believe, but hopefully you can kind of see how you can literally get started from 0 with Nomad and start scheduling some work on there. So in terms of the next steps, what I'd recommend and what I'm going to certainly go away and do as well, try this for yourself. Hopefully when you get this recording, you'll be able to watch this this video back again, and you'll be able to see if you know exactly how to go through these steps, such that it's not particularly difficult to actually do. The Learn portal and the guides. Let me show you those real quick now. So if I open this up in a new tab, oops, and then this in a new tab. I certainly cannot schedule 1 million containers on my MacBook, unfortunately, particularly when I have Zoom running. So the Learn portal, if you just go to learn.hashicorp.com/nomad, when that eventually loads, there is like a whole series of guides that you can actually run through that will show you right from installing Nomad, running Nomad, jobs, how to build a cluster up as well, and those different types of things. And then there is the guide section as well. So the guides basically allow you to go again through a series of steps. We're in the process of moving it from this page, so this guides page. They're slowly being migrated over to the Learn platform. So in some of these links you'll actually go to, you'll actually see they'll be on the Learn platform soon, if they're not already. Next step, check out the documentation. So go and take a look at the documents. You saw where that was on the Nomad website. Basically everything that I've showed you, all the job file specification, that's all in there. There are many things that we didn't have time to cover today. Those things are all in there. The next step would be to go and build a multi-cloud, multi-region cluster. So Nomad by default supports federation. So if you wanted to build this out in multiple data centers here in the EU, in the US, in Asia Pacific even, absolutely you can do that. You can even like submit a job to your local cluster, and in the job description you can say this needs to be run in the US, for example, and it will go and run it inside of the US cluster. And then the last step is go and deploy 1 million containers. Really simple. So let's take a real quick look, see how this job is going. And I can hit refresh a couple of times, and then I think we're open to Q&A. Yeah, there we go. Just things are running a little bit slowly on my Mac now because I've got so many different things running. But as you can see, they're all running. I'm going to stop those from running now, such that my MacBook's processor becomes happy with me again. But yep, that's it. So any questions? I'm just checking now. It looks like we've got a few questions through. Someone's asking, so a blog post to accompany this, then yes, absolutely. That's on my list of things to do. So basically, I'm going to turn this talk into a blog post as well. So you'll be able to actually go through this step by step without having to refer back to the video. Does Nomad have a way to run serverless apps like AWS Lambdas or GCP Cloud Functions? Really good question. As of things stand today, we don't have that capability. A lot of people are using Terraform to actually schedule those different types of things. But in the future, who knows? Maybe there will be some functionality like that. Nomad's a general purpose scheduler, right? It has a pluggable driver interface. So all the drivers I talked about today, they're basically plugins. Okay, so as people develop new task drivers, then we can actually import those into there. If we wanted to use Terraform with Nomad, and certainly you can use Terraform to spin up your Nomad clusters. So if you have if you have a need to spin up, particularly when you start spinning up thousands of machines, that becomes rather laborious if you're having to do all those things manually. So certainly you can use Terraform to actually spin that up. There is also a Terraform provider for Nomad, so you can actually use Terraform to submit jobs to Nomad as well if you wanted to. Is there any other way apart from Consul for dynamic port? Good question. So basically another service catalog. I'm not 100% sure about that one. I don't know if there are other things that integrate natively with Nomad. That's one of the reasons why people use Nomad is because it already integrates with other HashiCorp tools. Certainly all that information is available through the API though. So if you've got a system that can do API type queries, then you could do a query of the allocation and say, okay, tell me all the allocations for a particular job. And then those allocations will contain information about what ports are being used as well. Any way to use with OpenStack? Good question. Not entirely sure how to integrate this with OpenStack. You could certainly run it on OpenStack. If you're talking about scheduling things on OpenStack, again, good question. I don't know of a way off the top of my head. It might be another case of it's possible through the use of an additional driver. Is there any equivalent to Linkerd or Istio for Nomad, or is it not needed? Really quick question. It's Consul again. Okay, so Consul is service mesh. Obviously, I didn't have time to go through it all, but with my Mac, really is struggling right now with the kind of workload. If I go to the documentation section and the job specification, I'm just going to do this and then connect. So we have direct integration with Nomad and Consul Connect for service mesh. So yeah, does Nomad support a service mesh? Yes, it supports Consul Connect service mesh. How does Nomad handle state, specifically with long-running servers which may run on one node and get rescheduled? Again, there's a guide to this, so I recommend you take a look at that, which talks about running stateful workloads. So there's a couple of ways you can actually run stateful workloads with Nomad. There is also a talk by one of my colleagues. I can't remember what the talk was called, but basically where she talked through how you can actually do this. So there is actually a video available on the resources section. How would you map a yeah, I see you've great question. I can see you put it in both places. Awesome. How would you map a dynamic Nomad port to a static port in a Docker container? Good question. I'd have to check that one. It's probably part of the configuration as part of the job specification, where you basically say outside port is X and inside port is Y. But I have to double check that. Can we define dependencies between groups or tasks? That's another good question. Can we define it? So, you know, if you needed to start something up first before you started up another thing, good question. I know you can specify priorities, but yeah, I'd have to double check that one, whether you can actually specify the order in which you want jobs to be scheduled. So you need one system to come up and be healthy before you actually start another part. Pretty sure you can do that, but I'll have to double check on that. Does Nomad handle provisioning VMs, or is that something auto-scaling groups take care of? So as today, no, Nomad doesn't have the ability to spin up additional VMs. Obviously, you could do that with something like Terraform, or like you say, an auto-scaling group. So as you need to kind of spin up and burst. So a lot of people will run Nomads and then they'll burst. So we've got some people who run Nomad on-prem and they actually need to burst, and they burst into the cloud. So when they need that kind of elasticity, they burst up into the cloud, because obviously Nomad works across all of these different things. But Nomad itself doesn't have that kind of provisioning VMs capability. That's something that would be best left to Terraform. Just checking to see if there's any other questions. So I talked about how Nomad handles state. So I'm not going to answer that question about the rain in London, sorry. But yes. How to use Terraform with Nomad. So again, it's not a case of you probably wouldn't drive Terraform with Nomad. The way that I would see that integration working is you'd use Terraform to actually spin up additional Nomad clients. And then there's a follow-up to that. So thank you. I think that's all the questions answered. I think I've kind of checked them all. I think that's all of them. So any other questions? I don't think so.
Thanks for getting through all of those, Russ. So yeah, I guess if there's any other questions, quick, go ahead and type them. And otherwise, we will wrap things up. All right then, Russ. So thank you. Oh, wait, one more. Oh, just someone saying thank you. Okay, yes. So thank you for getting through all of those, Russ. And as I mentioned at the beginning of this Hangout, it was recorded, and we will make the recording available on our website after processing. I will send an email out to everyone who registered with the recording link. Also, if you liked what you heard today and want to start exploring Nomad, I encourage you to go to our Learn site. You can find it on our website at learn.hashicorp.com. So I hope you all enjoyed today's Hangout and have a better understanding of how to get Nomad up and running and how to scale your Nomad clusters. So thanks for hanging out with us today, and a big thank you to Russ for his time. That wraps things up for us. Thanks, everyone. Goodbye.
Thanks, everyone. Goodbye.